Use the color, please. Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Sibusiso Shongo, and this lesson is brought to you by the Saibono Discovery Center with the Gauteng Education Department. Right. Today we will be looking at part 1 of our revision for paper 1. Remember, the past 2 weeks we looked at a preparatory exam review where we reviewed paper 1 and then we also reviewed paper 2. So today it's our part 1 of the revision session where we're going to touch on one paper 1 topic and one paper 2 topic. In paper 1, I'll be looking at functions, interpretation of sketched functions. That's what I'll be doing with you. And then I'll hand over to my colleague, Mr. Nsindane, who will be taking you through Euclidean geometry. So it's important that we get to understand everything that we are doing today, because when we do our part 2 next week, we're just going to be looking at one topic as opposed to looking at many topics. So the day before you write, would have a session where we look at one topic, that would be differential calculus, and you look at one topic as well in paper 2. Right? Remember, you can also ask questions on our WhatsApp group. You ask questions related to the lesson that we are presenting today. The line is 064-748-8913. 064-748-8913. It will popping down on your screens as the lesson progresses. Right. To check here, I indicated that we'll be looking at functions here. Right. Obviously, we have our mark distribution and target setting. It's important you would recall that every time when we do our revision, we do put up our targets to say these are the targets that you can set for a pass and these are the targets you can set for a bachelor pass. Obviously, one that needs to obtain, or a learner that needs to obtain or has ambition of obtaining a distinction, then you should have your targets just above the targets that we put in there for bachelor pass. Right. Also, with your target setting, we did also highlight the weighting per topic, which is very, very important. It's important that you know which topic contributes a lot of marks, so that as and when you prepare, you spend a lot of time on topics that have a lot of marks, or that have contribute more in your final exam. Right. Now, obviously, there's the information sheet there. It's very, very important that you familiarize yourself with the use of an information sheet. If you haven't been using it up until now, please, from a preparatory exam question paper, please just take out that formula sheet. Familiarize yourself with it. Use it as far as you can. It is very, very useful, especially in topics like trigonometry, where you have a lot of formulas that you can use. So the formula sheet then becomes very, very important. Obviously, here I have some paper 1 formulas, and then here you can see it's some paper 2 formulas, and then you can see here paper 2 continued. On this slide, it's only formulas for trigonometry. Right, let's look at the summary of the functions and their parameters. If you check here, we have a straight line like that. We have a straight line graph. We can see that the domain is x, an element of all real numbers, and the range is y, an element of all real numbers. We are talking about a straight line. Obviously, we know a linear function that would be from minus infinity to infinity. It's defined from minus infinity to infinity, provided that there are those arrows there. You can see now we have a parabolic function here, a hyperbolic function, so to say, sorry. you can see that the domain would take all the real numbers but would exclude your asymptotes because it is not allowed to touch the asymptote. The range as well will take all real numbers but will also exclude the asymptote. So that's very, very important. And then we have a parabolic function. If you look at that, there is equation 1 and equation 2. That's very, very important because the forms in which a quadratic function can be written are different. You would recall in your preparatory exam paper, you were tested on equation 2 because the equation that you were given, it was given in a turning point form. So you were then supposed to then understand and be able to use your knowledge of the turning point form to can work with it. Remember also this one, this is the standard form ax squared plus bx plus c. Remember equation 2 is actually derived from equation 1 because if you are to complete a square for equation 1, it will take you to the turning point form. Now the domain there will take all real numbers. It will take all real numbers, but the range will always depend with the shape. The range will depend with the shape. If you have that this is a concave down function, then your range, in this case, your range should be y is less than or equals to, if the turning point here, the y value of the turning point minus p and q, the y value of the turning point is q like that, then you're going to have y is defined less than the turning point. So all the values less than the turning point are where the function is actually defined. So that would be your range in this case. Remember, domain will take all real numbers, but the range takes all values that are below the turning point. But here, if it's a concave up function, then it will take all values that are above. This is minus p and q. Y would be greater or equals to q. If it's concave up, then it is defined, the function is defined above at the turning point and above. Here it is defined at the turning point and below. Remember, the turning point is also included there. The y value of the turning point is included there. So it is at the turning point and below if it's concave down. It is at the turning point and above if it's concave up, right? Obviously, that's what we wanted to explain there, to say it will be like this, provided that the shape, you see here, a is less than 0, here a is greater than 0. So your range will depend on the value of a like that, because it depends on the shape of the function. Now the turning point, you can see for a straight line as well as for a hyperbolic function and an exponential function, we do not have a turning point. Those functions do not have a turning point. It is only the quadratic function that has a turning point. You know, there are 4 ways of finding that turning point. There are approximately 4 ways. The first one is to use x is equals to minus b over 2a to find the x value of the turning point, which is called the axis of symmetry, and then you are going to substitute that particular value in the original equation. That is why here they use minus b over 2a for x, and for y they use f of minus b over 2a, because where we see x we put minus b over 2a. Alternatively, obviously here we can, if we have the x-intercepts, we can find the midpoint. The axis of symmetry is the midpoint, or rather we are going to then say we add the x values of what? The x-intercept. The midpoint of the x-intercept would give us the axis of symmetry, and whatever value that you obtain there, you substitute it in the original. That is why you have f of x1 plus x2 over 2. Alternatively, if you have your turning point form, you can use minus p and q if you have your turning point form. Or you can also use calculus. In this case, you can use f prime of x. F prime of x is equals to 0 to find the axis of symmetry, and then you're going to take that value that you obtain, you substitute it back to the original equation to find the y value. So these are the 4 ways that you can actually use to find the turning point, or to determine the turning point of a quadratic function. Now with an exponential function, you can see the parameters p and q there. Remember, parameters p and q represent the horizontal and vertical shift respectively. Now you can see here that the domain of an exponential function, the domain, if you have an exponential function, the domain would always take all real numbers. For the domain for the graph to be defined, the graph is defined from minus infinity to infinity. It accepts all those real numbers. But now for the range also there depends on the value of a. If a is positive, you'll have that the range is y greater than the graph is defined above the asymptote. But if the asymptote, at times you find that now the graph is drawn below the asymptote. If the graph is drawn below the asymptote, then the range would be y less than q, like that. But here it would be y greater than q, because this is defined above the asymptote, but here you can see it's defined below the asymptote. So those were the parameters that we actually look at. Obviously we have the asymptotes. The asymptote for the hyperbolic function, you can see that this is x plus p. To actually get to the asymptote, you equate that to 0, and then x is equals to minus p, like that, when you transpose the p. So you get that the vertical asymptote, it's x is equals to negative p. It takes the negative of what is given on that particular equation. And then for the horizontal asymptote, obviously you're going to take this as your horizontal asymptote, right? And then from there we have the equation of the axis of symmetry. That would be the line that divides the graph into 2 equal halves. We normally say to get the positive axis of symmetry, we're going to use x plus p plus q. To get to the negative one, we're going to use minus x plus p plus q, like that. That is why it's written the way that it's written there. And then the axis of symmetry, if you check this hyperbola with parabola, we did not write down any of those asymptotes because it does not have asymptotes, but it does have an axis of symmetry. The parabola does have an axis of symmetry, which we get by using minus b over 2a, or would get it from x equals to minus p, or from f prime of x is equals to 0. Solving that equation gives us the axis of symmetry. Now looking at the exponential function, we only have the horizontal asymptote for that, which is y equals to q. Right, those are the parameters, is the summary of the parameters. Now good people, we move on to a few questions that we actually have to respond to. These are the examples of the interpretation of sketched functions. Look at the first one, example 1. The function f of x is equals to x minus d divided by x minus p is sketched alongside where p and q are constants. The dotted lines are the asymptotes. Point B with values 2 map 0 is a point on f. The asymptote intersect at P. The asymptotes of this graph, they intersect at P. So point P is a point that represents the intersection of the asymptotes. Now determine the values of D and P. Determine the values of D and P. Now from here, we are going to be taking this equation. If you check the asymptote here, the vertical asymptote x minus p, like that, we can get it this way to say we have that x minus p is equals to 0, and then which means that x is equals to what? X is equals to p. That would be the asymptote, but the asymptote is given there as minus 1. X is minus 1. So x is minus 1, which means that p, therefore p is equals to negative 1, like that. So we've worked out the value of p. Now we want the value of d. Now to work out the value of d here, we come back to this. We say f of x is equals to x minus d over, we can substitute the p now, x minus p, like that. And then now if you check from this, or rather f of x will then be equals to, I should take this away, I wanted to substitute that point there, so it's x minus d over x minus -1 that we got. That's what I wanted to do there. So we have that f of x is equals to x minus d over x plus 1. So I just substituted the value of p there. Now if you check here, this, if you substitute a point at b, we are given a point b, at b is 2 and 0. If you substitute a point b there where x is 2 and y is 0, the only unknown would be the value of d. Let's substitute and see. Now where we see x, we're going to put 2, and where we see y, we put 0. So y is 0, 0 would be equals to x is 2 minus d divided by 2 plus 1, like that. So that's what we did there, we substituted. Now 0 is equals to 2 minus d divided by 3, like that. So if I multiply both sides by 3, the LCD, I'm going to get that 0 is equals to 2 minus d, which means that d is equals to 2, like that. So I've worked out the value of d as well as the value of p. We move on, good people. We move on. Now they want us to show that the equation of f can be written as y is equals to -3 over x plus 1 plus 1. Remember the equation, we got the value of d, which is x minus 2, and we got the value of p, which was x plus 1, like that. So this is our equation. This is our equation when we substitute d as well as p. That's what we get, like that. So now we want to write it in this form. So the best way to do it would be, you look at the denominator, you should be guided by the denominator, and you express your numerator in terms of what? In terms of the denominator, so that these two can divide out. So in order for me to have something that would divide out x plus 1, I need to have x plus 1 in the numerator, like that. So now obviously this thing, when I add whatever, I would then say minus 1 minus 2, like that. If you check minus plus 1 minus 1, it still gives you these two values, they still give you 0. So which means that I am actually in order. There is nothing wrong with what I did. I am saying here, I'll repeat what I said. I am saying here, this is written as y is equals to x minus 2 over x plus 1. I'm guided by the denominator there. So I want to express my numerator in terms of the denominator so that I can divide this into two fractions. So now what I can do is, because I have a plus 1 in the denominator and in the numerator I don't have a plus 1, I will strategically add 1 and subtract 1. Adding 1 and subtracting 1 is the same as just putting 0 there, putting nothing. So, but it assists me mathematically because the plus 1 is going to be grouped with the x so that it's the same as the denominator. Now from here I can then say this is x plus 1, and then I add these two, minus 3 over x plus 1, like that. So now if I continue with this here, you can see there's a common denominator, which means that I can divide the first terms by the denominator and divide the second term by the denominator, like that. So which means that now I can write this as minus 3 over x plus 1, and then this whole thing here would simplify to 1. So y would be equals to minus 3 over x plus 1 plus 1. So we were able to show that it can be written that way by using what we originally had there. Right, I'm moving on. Write down the coordinates of P. Remember, we have our equation as y is equals to, let's go back, minus 3 over x plus 1 plus 1. Minus 3 over x plus 1 and then plus 1, like that. That is the equation that we have. Now, they want the coordinates of P. And we're told that P is the point of intersection of the asymptote, which means that if we can find the x asymptote or the horizontal and vertical asymptote, we can get that x plus 1 is equals to 0, x equals to negative 1, and then y is equals to positive 1. So that's where we have our negative 1 and our positive 1 meeting here, which means that point P would have coordinates negative 1 and 1, because that's where the asymptotes intersect or meet. Now, D here they say, is f an increasing or a decreasing function? Is f an increasing or a decreasing function? Normally, when I want to look at increasing and decreasing nature of the function, I make use of a toy locomotive or a toy car. I'm going to be moving this toy car from left to right on my function. And if the toy car is moving uphill, I'm saying the function is increasing, but if it is moving downhill, then the function is decreasing. Now, if I were to place my toy locomotive here, you can see that now it will be going up. So it means that the function is increasing. Even if I place it here on this portion of the graph, you can see that it would be going up. So this, it represents what now? It represents an increasing function, because you can see that your toy locomotive is going to go up. So it increases going up. So you say that the function is increasing. Alternatively, you can use the gradient of a tangent to actually explain. You can see that this portion of the curve has a positive gradient. So it's an increasing function. Also, this portion of the curve has a positive gradient, which means it's an increasing function. Or you can check what happens to y as x increases. From this graph, from left to right, you can see as x increases, y also increases. So this is an increasing function. So they say write down the values of x for which the function increases. The function increases for x an element of all real numbers. It increases everywhere except at what? Except at the asymptotes, like that. So it increases everywhere, starting from negative infinity to negative 1, and then after negative 1 to infinity. So which means we can also write it this way. We can say x an element of, starting from this side, it's from minus infinity to negative 1. So this is negative infinity to negative 1. That is where this portion is increasing. But now we need to define this portion. And this portion is unified with the first portion. And then it starts here at negative 1 to infinity. These two things mean the same thing. They mean the same thing. Right. I'm moving on. Write down the domain of g of x if g of x is f of x minus 2. So there are two ways in which you can write this domain. I'm just going to do one of the ways. Where the first way is to look at the original domain and then check the transformation and transform the original domain. An alternative way would be to find a new equation, and from the new equation then determine the domain by finding first the equation of g, and then from the equation of g, using the transformation, you find the domain. So let me look at the first method. The first method that I spoke about is we're going to find the domain of the original function. The domain of the original function is x an element of all real numbers, but x cannot be equals to negative 1. It cannot be equals to the asymptote. Now, let us look at the shift or the transformation. What is the shift or what is the transformation? The transformation here is this here. X minus 2 is equals to 0. X is equals to 2, which means that all the points on F are going to shift by 2 units to give you the points on G. So this is the domain of what? Of F. So to find the domain of G, we need to apply what? The transformation. We transform the domain of F to get the domain of G because we know the transformation. So the domain now, domain of G is now going to be X, an element of all real numbers, but X cannot be equals to -1 moved 2 units up, because the transformation says move all points 2 units up. That is the transformation. So we get that X is an element of all real numbers, but X cannot be equals to 1. That is how we find the domain of G. That is how we find the domain of G. Right, we move on. Now, the second function here in this case is a parabola and a straight line. We are interpreting a parabola and a straight line. Now, let's quickly go through that. The functions f of x is -x squared minus 2x plus 3, and g of x is mx plus c. You can see that g of x has parameters that are unknown. Now, these functions are drawn with G passing through E, C, and A. F cuts the x-axis at A and B. CD is the x-axis of symmetry of F. G cuts the y-axis at point E, from just like you can see when you look at the graph like that. So now, they say determine the coordinates of C, the turning point of the graph. Remember, another examiner may not be this lenient and say the turning point. He will just say determine the coordinates of what? C, because already they have told you maybe in the statement that C is a turning point, or you can see from the graph there that C is the turning point. So how do we find the turning point? Last time there I showed you, when I was still looking at parameters, I showed you the 4 ways that you can use to find the turning point. I'm going to use one of the ways. The most common one would be minus b over 2a. So x would be equals to negative 2 over 2 negative 1. So this x would be given by -1. That would be the axis of symmetry, or rather the x value of the turning point. Now, obviously, if we want to find y, we are going to substitute -1 on the original equation. So this is negative into -1 squared minus 2 into -1 plus 3. This will simplify to, if you are to put that in the calculator like that, you should be getting 4. You should be getting 4, because this would be -1 plus 2 plus 3. That would be 4. Therefore, here the coordinates of C would be given by -1 and 4, like that. The coordinates of C would be given by -1 and 4. Right. Let's move on. Determine the coordinates of A and B. We already know the coordinates of C. We said it's -1 and 4. Now we want the coordinates of A and B. The coordinates of A and B. If we look at A and B here, we can see that they represent the x-intercept of the function f. They represent the x-intercept of the parabola f. So we're going to say that for x-intercept, y is equals to 0. So if y is 0, this would be -x squared. If y is 0, this would be -x squared minus 2x plus 3, which means that if I want to write it in standard form, I can divide by -1. X squared plus 2x minus 3 is equals to 0. I can find factors, or I can use my quadratic formula if I cannot. So this is x, and then the factors of 3 that are going to give us 2, that would be 3 and 1. The 3 should be positive, 1 should be negative. So x is equals to 1, or x is equals to -3, like that. So we check from the graph which one is positive. The one that is positive is for B. So we're going to then say, okay, since the one that is positive is for B, then we're going to say x of B is 1 and x of A is -3, like that. So we have the coordinates of A and B, which means that therefore the coordinates of A would be, when x is when x is negative 3, y is 0. And the coordinates of B would be when x is equals to 1, y is 0, like that. So those are the coordinates like that. So now they want us to determine the values of M and C. Remember, M and C are the parameters of our straight line. So M represents the gradient. So we need to find the gradient as well as the y-intercept of the straight line. So now let's quickly go through that. The gradient, obviously, we will need the points on the graph. We do have point A. We do also have point C, which is negative 1 and 4. So to find the gradient of AB, we are going to say y2 minus y1. Remember, we have the point here minus 3 and 0. We have a point here minus 1 and 4, like that. So now we want to find our gradient. So we're going to say y2 minus y1, which we can take 4 minus 0 over x2 minus x1 minus 1 minus 3. So this would simplify to 4 divided by 2, which is equals to 2. So our gradient is equals to 2, which means that M is 2. We now want to find C. So we can use y is equals to mx plus c and substitute the gradient and any other point on the graph. So if we substitute any other point on the graph, we can use on the line. We can use minus 3 and 0. So if y is equals to 0, like that, I'm using this point here. If y is equals to 0, and then this is equals to, the gradient is 2, x is equals to, x here is negative 3 on that point plus c. So c would be equals to what? 6. So we have m is 2 and c is 6, like that. It's just like in analytical geometry where they ask you to find the equation of the line. You find that if you check what you are given. If you are given 2 points, you are going to use those 2 points to find the gradient, and then from there, after finding the gradient, you can find the equation by using a gradient and a point, right? Now moving on, calculate the length of CE and leave your answer in set form. Calculate the length of CE and leave your answer in set form. Now let's look at the coordinates of C, the turning point. We said it's minus 1 and 4. That's what we said. We said it's minus 1 and 4. And then what are the coordinates of E? E is the y-intercept. Remember, we found the values of M and C. So we know g of x is equals to 2x plus 6. And E, you can see point E is the y-intercept of this. So C is given by negative 1 and 4. That is our turning point. And E is the y-intercept of what now? The straight line. The y-intercept would be when x is equals to 0. So this is g of 0 is 2 into 0 plus 6. The y-intercept is going to be 6. So which means point E is 0 and 6. Now if we want the distance or the length of CE, then we use the distance formula. This would be x2 minus x1 squared plus y2 minus y1 squared. So this would be equals to the square root of x2 minus x1. That would be 6 minus 1. That is 6 plus 1 all squared. No. Let me fix that. x2 minus x1. That would be 0 minus 1, 0 plus 1, because this is xy, 2 xy, 1. So y2 minus y1, this is squared, and then plus y2 minus y1, that would be 6 minus 4 all squared. So if you are to use your calculator and you punch that into your calculator, you get that CE would be the square root of 5. So that is why here they said you can leave your answer in set form. They don't want you to write it as a decimal. Now the next question, calculate the size of ACD. They want this angle ACD. They want that angle there. calculate the size of what? Of angle ACD. There are so many ways that one can use to calculate that particular angle. But now remember, in grade 11 you did analytical geometry. You spoke about the inclination of a line segment. So if we have this line, we can use the gradient of that line to find the inclination. So the gradient of C or AC or AE would be equals to what? The tangent of what? This angle. How do we define this angle? It's CAD. So now we are given that we've worked out, remember we've worked out this gradient. We got that it's 2. It's the gradient of the straight line. So the tangent of CAD is equals to 2. Remember, I am on E now. So I want to find angle CAD. If I want to find CAD, I would use the arctangent of 2 in my calculator, which I will then get the arctangent of 2. So CAD is going to be equals to 63,43 degrees. Now that we know in this triangle, we know this angle is 90. We know this one is 63.43, which means that therefore, if we want to find angle ACD, if we add all the angles, they are going to give us 180 degrees, sum of interior angles of a triangle. So this would be 180 minus, remember this is 90, this is 63.43, minus 90 minus 63.43. This gives us an angle of 26.57 degrees. So that's how you find that angle. We are using analytical methods. So you can see that this question is integrating paper 2 concepts together with paper 1 concept. So that's very, very important. When you write paper 1, do not think that there won't be any integration of topics. Even with paper 2, they sometimes integrate that with paper 1 topics. So it's important that you know your mathematics there, because you are dealing with lines. Once you deal with lines, there's a possibility of talking about inclination. So please make sure when you prepare, you also look at the questions in paper 1 that speaks to inclination. There are so many of those questions from past exam papers. Can use them to practice. Right, I'm moving on. Write down the values of x for which f decreases. Write down the values of x for which f decreases. So we want the values of x for which this graph decreases. Now if we check here, the turning point, we said it's -1 and 4, like that. Write down the values of x for which it decreases. Now if you check here, this function, as you go up, if you are to put your toy locomotive, as you go up like that, you can see it's increasing here. So it gets to the turning point. When it gets to the turning point, it stops. That is why we call them the stationary points, because it is stationary there. So it increases here, and then after the turning point, what do you see? You see that it's going downhill, which means that now this side it is decreasing, and this side it is increasing, like that. So now we want to see, or rather we want the region where the value or the function decreases, the values of x where the function decreases. So we are interested in where it decreases. Where will it decrease? It decreases starting from the turning point, just after the turning point, going down. What is the value of x on the turning point? It is -1. So starting from -1, going that way, going this way, starting from -1 on the graph, going that way, you can see that it increases when you start from -1 going that way. So this starting from here, going that way, you can see that now it starts decreasing. So it decreases when x is what? X is greater than -1. Decreases when x is greater than -1. So that's very, very important. When x is greater than -1. So that's where the graph of f decreases. Now, last question. This would be the last question for today. Determine the values of k for which f of x equals k has two real but unequal roots. Determine the values of k for which f of x equals k has two real but unequal roots. So they are interested in what? Real roots that are not equal. And here we are given f of x equals k. Now I'll give you a strategy of answering these questions. Now you are given f of x equals k. What is f of x? It's y equals k. So this is the line. This is the line that is drawn. It's line y equals k. It's a horizontal line. You know, if I can say to you, draw a line y is equals to 2, obviously you'd draw that line. This would be the line y is equals to 2. If I say draw a line y is equals to -3, you'll put a line here, y is equals to -3. So here it's line y is equals to what? K, where k is the parameter that we are investigating. So line y equals k is a line that we are going to use. We subject that line to this graph and see where these conditions would be met, where we would have two real and equal roots. So you are going to move a horizontal line on the graph. Just like you draw any line y equals to 2, you're going to draw a line y equals k, where k is unknown. You check with that line. This line must give you two real and equal roots. What are roots? Roots are x values. Right? Roots are x values. So you are saying or rather the question is actually saying, in actual terms, it is saying to you, draw a line on the graph, a horizontal line on the graph, and find where the graph would have two real x values, two unequal x values, because we said roots are x values. So where can we actually subject this line so that it has two, or it cuts the graph on two different points? That's what they are saying. Now I'll draw a line of interest. If you are to put a line here, let me just redraw this graph like that. Let me redraw this graph like that. Now the turning point here is -1 and 4. If you are to put your line here, right, line y equals k, if you are to put it there, how many times is it touching the graph? If you look at your screen and look at where I drew the line and tell me how many times it touches the graph, obviously you would see that it touches the graph once. So it does not have two roots, it has just the one root. But if you are to move this line here, look at now what is happening. The line is now touching the graph on two different points. What are those points? Roots. And they are not equal. If you are to move it further down, you can see it touches the graph on 2 points. Further down, it touches the graph on 2 points. Further down, it touches the graph on 2 points. So you can see from here that if the line is just below the turning point, if this line is below the turning point, then what happens? It starts touching the graph on two different points, right? Just below the turning point. At the turning point, it touches once. Below the turning point, it touches the graph on two different points. That is what we are looking for. So it happens everywhere here, everywhere below the turning point. So everywhere below the turning point is where the condition is met. Now, how do we describe that? Remember, it will happen when y is less than what? Y is less than 4. It will happen when y is less than the value of the turning point at that region. But what is y? We said y equals k, which means that k would be less than what? Less than 4, like that. K would be less than 4, like that. So that is how you actually work out these nature of roots from what? From the graph. Remember, when these questions are asked in a graph, then it means you have to use the graph. You don't have to use the discriminant. You have to use the graph. Right, good people. I think we've done enough of what I actually had planned for us to do. We looked at parameters, and then we looked at the interpretation of a hyperbolic function that was sketched, and we looked at the interpretation of a parabolic function that was sketched. Remember, it goes on to inverses, right? It goes on to exponential functions. Please, as and when you do your revision, revise those questions on inverses where you interchange x and y. Very, very important. So I would leave you for now. I am saying goodbye to you. I'm going to hand over to my colleague, Mr. Nsindane. We're just going to take a 5-minute break. Then I'll hand on over to my colleague to do Euclidean geometry. So from my side, it's thank you and bye-bye. Welcome back. We continue with Euclidean geometry. I hope you have stressed and refreshed. Now, last week we looked at the proofs of our theorems. So this week we will continue with the riders and remind you of all the theorems that you must know in order to help you answer questions in Euclidean geometry. Now, just a quick run. We will keep on reminding you so that as you set your targets,
you practice, you keep on checking yourself whether you are able to meet your target or not. Now, in order for us to get 45%, we need at least 57 marks, in which in statistics we must get a minimum of 12, analytical geometry a minimum of 15, and trigonometry a minimum of 20, and Euclidean geometry a minimum of 10. If we are aiming for a bachelor pass, those are the targeted marks. So as we do activities, let's always check if we are able to meet the target. Moving along, in Euclidean geometry, we must know all the theorems that we did in grade 11 and earlier grades. We must be able to visualize in Euclidean geometry, and we must be able to remember the properties of lines that are intersecting, and we must know the properties of all the triangles and the properties of all the quadrilaterals. We must remember the midpoint theorem, which is a special case of proportionality theorem. Now, we must also be able to know the converse theorems, and we also look at the application of Pythagoras theorem. Now, we have learned that if we are having parallel lines and there is a transversal line, then we must have corresponding angles, we must have co-interior angles that are supplementary, and we must have alternate interior angles that are equal. And then we should also be able to see that if we have corresponding angles or co-interior angles or supplementary angles or alternate angles that are equal, then we must know that the lines are parallel. For our triangles, we normally forget this. The sum of interior angles in a triangle add up to 180 degrees. We also know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. We know that if I have A and B, then C will be equal to the sum of the two. Now, let's quickly look at the theorems that we must know. These are the theorems that we have learned. We know that the line segment joining the center of a circle to the midpoint of a chord is perpendicular to the chord. That is the diagram that we are having there. And there we are given that AM is equal to MB. Our aim in most cases will be to prove that M1 and M2 are 90 degrees. The converse, we know that the perpendicular drawn from the center of a circle to the chord bisects the chord. We know that theorem, and we looked at its proof last week. We will move along. We know that the angle subtended by a diameter at the circumference is 90 degrees. So if C is 90 degrees, then it will follow that AB is the diameter. And we know the parts of a circle. Please, let's revise the parts of a circle because we forget some of these things. Now, so we know that if C is 90 degrees, then AB is a diameter, and we know that if we are supposed to find the size of angle C, it will be 90 degrees, and we know that it's an angle in a semicircle or angle subtended by a diameter. Please, let's go back to our examination guidelines so that we write the correct reasons whenever we are writing these statements. We'll move right along. Now, the angle subtended by an arc or a chord at the center of a circle is 2 times the angle that is subtended by the same arc or chord at the circumference. These are the versions of the diagrams that we must know for angle at center, 2 times angle at the circumference. Now, we also know that in the diagram, we know that if we are having an arc or segment, we are able to find the angles that are equal and we are able to get them. The next theorem, these are angles that are subtended by the same arc or chord on the same side or angles in the same segment. You will realize that our angle A will be equal to the angle B because they are subtended by the same arc CD, or if it's a chord, it will be chord CD there. And if you check, angle D will be equal to angle C because they are subtended by the same arc or chord AB on the other side, if we are looking at the arc there. Now, we'll move on to the next theorem. Familiar one. We know this one. The opposite angles of a cyclic quadrilateral are supplementary. Supplementary means they add up to 180 degrees. So, if D is theta, it will follow that our angle B becomes 180 minus theta because these are opposite angles of a cyclic quad. The converse of that theorem, we know that if we have opposite angles that of a cyclic quad that are supplementary, then the quadrilateral is cyclic. That's what we should know. And if we're able to prove that, then it follows that ABCD is a cyclic quad. And when we give a reason, it's the converse of the cyclic, of the opposite angles of a cyclic quad. We move on now to the next theorem. The exterior angle of a cyclic quad is equal to the opposite interior angle. So if I have C1, it will be equal to angle A because this is a cyclic quad. We must know also the conditions of how a shape can be a cyclic quad. Now, you are able to prove, if you are able to prove that C1 is equal to angle A, then we are able to conclude that ABCD is a cyclic quad using the exterior angle of a cyclic quad is equal to the opposite interior angle. Now, we all know that a tangent is always perpendicular to the radius. Hence, we should be able to use that theorem that a tangent is always perpendicular to the radius at the point of contact. Remember, a tangent is a line that only touches a curve at only one point. So the converse, we know that if a line is drawn perpendicular to the radius at the point where the radius meets the circle, then the line is a tangent. We move along. We know that if two tangents are drawn from the same point outside the circle, then the two tangents will be equal in length. And we also know that the angles that they form will be equal to 90 degrees when you join that to the center and you form a shape which is a quadrilateral. It is four-sided. We move along. Then the angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. Now, if you check, BD is a chord, we are able to see that one. If I look at this, ABC is my tangent. This is the angle between a tangent and a chord. You are able to see that that angle is equal to the angle B2 because this is the angle at the point of contact. This is the angle in the alternate segment. Now, If you check B1 as well, B1, our BE becomes a chord, and that is the angle subtended by the chord BE, so that we are able to form angle D on the other side. It will be equal to the angle B1. We move on. The one that is easily seen is the second diagram. That one where we have the first diagram, this one, most of us fail to see that one because we always are used to seeing that one. This is our center O. You are able to see that B1 is also equal to D and B2 is equal to E, which is our turn chord theorem as the reason. Now, the converse of this theorem, if we are able to prove that angle D is equal to angle B1, it would mean that ABC is a tangent to the circle passing through the points BDE. And this is a common question, and we are going to look at one which looks like that. We will move along. We looked at the theorems that we are supposed to prove in the exam, and we proved them last week. This is just a reminder so that you are able to go back and revise them. And remember, whenever you are proving a theorem, you must be able to do a construction, or you must have a construction statement. Otherwise, there is no mark that you are going to be awarded, even if you know the proof. If there is no construction or construction statement, it becomes a breakdown. We cannot mark if there is no construction or construction statement. The line drawn from center of a circle perpendicular to a chord bisects the chord. I have gone through these theorems and their converses, so for you it's just to run them down so that you remember the 7 that are examinable and you go over them again. Now, I have highlighted that it's important for you to construct or write down the construction statement. We move on now. The types of questions. In Euclidean geometry, we have 3 types, where we have our numericals in terms of x and any other variable, and then we also have the proofs. Prove that the shape is a cyclic quad, prove that the line is a tangent, and the proofs of the 7 theorems that I have highlighted above. We have proportionality and similarity, where we work on one triangle at a time. We look at the lengths, we look at the ratios and the lengths, the 2 ratios. When you are given one ratio, where you step it up to the other side. And then we also look at area, where we have common angles, where we use area rule, and we also have a common height. We looked at it when we did the proof, and it applies in our questions. We must practice questions there. Now we have similarity, where we work with 2 triangles, direct application, where you are able to prove that the angles are equiangular, then the 2 triangles are similar, or if the sides are in the same proportion, then the triangles are also similar, and you are able to either directly apply the theorem or indirectly apply the theorem. Now, here are the tips of how we solve questions in Euclidean geometry. Read, read, read the information next to the diagram thoroughly. The challenge is we are quick to just look at the diagram and want to answer without understanding the scenario. Please read the information. It is important. And as you are reading the information, if it's not included in the diagram, add the information in the diagram so that you are able to see the information that you have, and it also helps you to visualize what can help you solve that particular problem if we have added the information. Now, use of colors is encouraged so that you are able to highlight certain angles that are equal or certain sides that are equal. It will make life easier because it helps you to see which theorems you can apply there. Now, implied information should also be deduced and you add it to your diagram to help you see what can help you. You brainstorm the solution. Remember, if a question says, prove or show that AB is a tangent, you cannot start by applying the Tan-Code theorem because it must come at the end. You are not proving, you are using what you are given and you will not be awarded a mark there. Now, the last step, you write down a formal solution and remember it must be logical. What must come last must come last. It can't come first. Yes. So, I will give you 5 minutes to answer this question. It's a numerical. So I'll give you 5 minutes. You answer that question. And when we come back, we'll quickly mark it and then we'll move on to the second type of questions, which are the ones that involve variables. I hope you had a good time to just work out that problem. I know 5 minutes was a bit short, but this is how we do things. Quickly have a quick way of doing things so that you are able to see the theorems that are there in the diagram. I always encourage people to say, before you look at the questions, you have read the information. It says ABC is the tangent to the circle center O at B. F, E, and D are points on the circle. EF is equal to BF and ABF is equal to 32 degrees. The moment you see a tangent, you know that somehow you have to apply the tan-chord theorem, or also you must know that you have to use the theorem that our tangent is perpendicular to the radius. So let's quickly look at the angles that are going to be 32 degrees. If I check, BF is a chord, so it means E1 will be 32 degrees. I'm adding it to the diagram. Also, if I look at B1, will also be 32 degrees because these become angles opposite equal sides, because our E1 and B1 are opposite EF and our BF. I'm also able to use sum of angles in a triangle. I'm able to get my angle F, which will be 180 degrees minus 64 degrees, and that should give me 116 degrees. So I have angle F. Using that, I'm also able, if I look at B, D, E, F, I'm seeing a cyclic quad because all the vertices are on the circumference. I'm able to get that angle. If I check, angle F is opposite angle D, so this should also be 64 degrees because these are supplementary. Now, I'm also able to get which other angle? I'm also able to get this angle here. I'm able to use angle at center 2 times angle at the circumference. So this angle will be 128 degrees there. I'm also able to get, I know that this side is equal to that one because these are radii. So I'm able to get my E2 and my B2. So looking at that diagram, I'm able to see that E2 is equal to B2. So I'll say 180 minus 128 minus 128, and this will give me 52 degrees. I divide that by 2, it means this one will be 26 degrees and also this one will be 26 degrees. Now, these are angles that I'm easily able to see how I got them before looking at the questions. Now I'll go to my questions. The first one, E1, 32 is going to be equal to 32 degrees. My reason, remember, as you are filling in the diagram, you are able to see what are your reasons. If you look at angle F, we found it as angle F is going to be 116 degrees because we first of all found B1 as 32 degrees, then we used sum of angles in a triangle and we got it as 116 degrees. So statement, reason, and the reason there, we get our 2 marks. 8.3, we have to find angle D, and if we have angle F, we can use that these are opposite angles of a cyclic quad. D will be 64 degrees, we get our 2 marks. O1, we are able to get our O1 as 2 times angle D, which will give us 128 degrees, and our reason becomes angle at center is 2 times angle at the circumference. We'll move along. Yes, angle at center, 2 times angle at the circumference. And then for our E2, we have different ways of getting that one, but I've given you the easiest one. Already we have this as 64. We have this one as 128. We can just use sum of angles. We know that this is equal to that one. And then we get our angle as 26 degrees. Alternatively, our angle B1, we found it as 32 degrees. So we are able to use our B1 plus B2 plus 32 degrees is equal to 90 degrees because this is a right angle. And then we are able to find our B2 as 26 degrees. And then we know that these are angles opposite equal sides. So B2 will be equal to angle E2. And we got our answer as such. We move on now to the next question. It's a proof of a theorem. Angles in a cyclic quad. So remember what we need to do first. Our construction or construction statement. We have to prove that angle J plus angle L is equal to 180 degrees. Please do not construct from J or L, so we'll make a construction OK, and we also make a construction to OM, and then we can name this one our 1 and this one our 2, and then from there we do the proof. So here is our construction. It doesn't matter how you do your naming, but this is how it's done there, and you are able to do the construction like that for 5 marks. So the first mark is for the construction. O1 is equal to 2J angle at center twice. You get your second mark. O2 is equal to 2 times L. You get the third mark. And then you must know that our O1 plus O2, these are angles around a point. And then you equate to 360. You take out a common factor. We get our 5 marks there. We move on to the next question. Now, because of time, I will work through the question, but I will work through it slowly to allow you to work through the question. I'll just give you 1 minute where you are going to read the statement above. Before you look at the questions, try to indicate in your diagram the angles that are equal to angle X, and then we will take it from there. So it says in the diagram, BE and CD are diameters of a circle having M as the center. Chord AE is drawn to cut CD at F. AE is perpendicular to CD. Let angle C be equal to X. The first question says, give a reason why AF is equal to FE. Now, to answer the first question, M is the center. So MC is a line drawn from center. And you are able to see that MF is perpendicular to AE. So for 10.1, our reason will be line from center perpendicular to a chord. Perpendicular to a chord. That is the reason why we have to give a reason why AF is equal to FE. Line from center perpendicular to a chord. We know that it bisects the chord, so we are able to see that this is equal to that because it's a line drawn from center perpendicular to a chord. The second question, determine with reasons the size of M1 in terms of X. we want to find M1 in terms of X. Which theorems do you see there? I'm seeing triangle ACF, and then I'm also seeing so many triangles there, but we have to find the size of angle M1. If I check, I am able to see that theorem. So I know if I get this angle here, that one becomes twice that angle. So my job is to find the size of angle A1 first before I can get M1. So if I look at that one, my angle F is 90 degrees, that one is X, so I can use my angle A1 is equal to 90 degrees minus X. These are sum of angles in a triangle. Now, from there on, I'm able to see that my arc CE is subtending this angle A1 and that angle M1. So I'm able to see that my angle M1 is equal to 2 times my angle A1 using angle at center is equal to 2 times angle at circum. So it means M1 will be equal to 180 minus 2x. So here it's 90 minus x. Here it's going to be 2 times that. It will be 180 minus 2x. Prove giving reasons that AD is a tangent to the circle passing through A, C, and F. Here are the questions that there is no circle there. It's an imaginary circle, but we have to prove that is a tangent. Remember, we said we have to prove that one of the angles is equal to that particular angle, even if so. In short, let me just do that. It won't be a perfect circle. So, in other words, we have to prove that our AD, that's our AD. So in short, we have to prove that our angle A2 is equal to X as well. So how do we do that quickly? You are able to see that if you look at triangle ACD, you are able to see that our angle A1 and A2 is 90 degrees because they are subtended by a diameter CD. And then from there on, our job is to show that A2 is also equal to angle X, just like our angle C. So we'll move along. So we start by giving CAD, which is our A1 plus A2 is 90 degrees. These two here are 90 degrees. But remember, we have found our A1 as 90 minus X because using sum of angles in a triangle. So we find A2 as 90 degrees minus 90 minus X, and we get our A2 as X. And then we are able to show that A2 is equal to C because they are both equal to X. And remember, you don't say Tancourt theorem, it's the converse of the Tancourt theorem there. And then 10.4, given that CF is equal to 6 units and AB is equal to 24 units, calculate giving reasons the length of AE. So to find the length of AE, first of all, we are able to see that if you look at triangle ABE, we have we know that our FE is equal to our AF, line from center perpendicular to the chord, and also this angle is 90 degrees. That one is also 90 degrees. This angle here is going to be 90 degrees because BE is a diameter. So it follows that our EM is also equal to our BM. So we know that if a line is drawn from the midpoint of one side of the triangle to the midpoint of the second side, it will be parallel to the third side and its length will be half the length of the third side. And this is what we call our midpoint theorem. So using that theorem, we are given that our CF, which is given there, we are given that our CF is 6 units. And then if CF is 6 units, we are also given that our AB is 24 units, which means MF is half of AB, hence this will be 12 units. We are able to get our CM, which is our radius, as 18 units, meaning our ME, remember this one, AB is 24, so this is going to be 18 units, because our radius is 18 units. So BE is going to be 36, this is 24 as we were given. So from there on, we are able to use the midpoint theorem to get our FM, which we have found as 12 units. And then we know that EM is equal to MB equal to CM because these are a D, they are going to be 18 units. And then FB is going to be 36 units. I've indicated there on the diagram. Our triangle ABE is a right angled triangle. We then use theorem of Pythagoras to find the length of AE, and we find it as 12 root 5 units. Now, here is another question that I would love us to quickly go through it so that we are able to see how we can tackle questions in an exam. The diagonals of a parallelogram KLMN intersect at P. NM is produced to S. R is a point on KL and RS cuts PL at T. The ratio NM to MS is 4:1. NL is equal to 32 units. TL is equal to 12 units. Determine with reasons the value of the ratio NP to PT. These are the kind of questions that we are going to meet in the exam. Now, the first thing that we must do here, we must know the properties of a parallelogram. If we do not know the properties of a parallelogram, we will get stuck. Now, we are given that NL. If you check, NL is a diagonal, and also KM is another diagonal because we are talking about a parallelogram. So we know that our NP should be equal to our PL. So because the diagonals of a parallelogram bisect each other. So this is equal to that. This is also equal to that. So we need to know the properties of our quadrilaterals. So it means our NP is going to be 16, which means our PL is also going to be 16 units. Now, what are we told? We are told that the ratio of NM to MS is 4:1. Now we have to determine with reasons the ratio of NP to PT. So I will move along. I've already given the reason. NP is equal to PL equal to 16 units because these are diagonals of a parallelogram, meaning PT is going to be 4 units. So this part is 4, that one is 12 because we have shown that this is 16. So NP, you are able to see our NP. Our NP, we found the length as 16. So 16:4, which reduces to 4:1. Prove with reasons that KM is parallel to RS. Remember, we are not given that. How do we prove that they are parallel to each other? We are able to show that the ratios are the same. And then, therefore, they are going to be parallel to each other. We'll 9.2.3. We are able to use now the proportionality theorem. We are supposed to find the length of our RL. So RL, we have proven that these are parallel to each other. So we know that. And we are able to get our KL. We are also able to do that, and we are able to do that, so that we are able to get the length of our RL. So we will substitute, and then we'll get our RL as 15.75 units. Statement and reason, we are using the proportionality theorem, or line parallel to one side of the triangle divides the other two sides proportionally. Now, this is another way also where we will be tested on our similarity theorem, where instead of proving the whole theorem, they bring it in bits and pieces, where you have to prove that the two triangles are congruent first, and then you have to prove that DE is parallel to BC, and then you have to prove the theorem at the end. It's an interesting way of asking the proof of a theorem in bits and pieces, but we must know the proof of the whole theorem, and we did it last week. So we will move on because we did the proof of this theorem. Ours is to just put the bits and the pieces together so that you are able to answer these questions. Now, in conclusion, please let's analyze the information that you are given in a diagram. We always link the statement to the correct reason. We must know the wording in our theorem so that we are able to remember the statement and reasons from our examination guidelines, and we have been working with them since grade 10. So they should have stuck now. It's easy for us to get marks in Euclidean geometry because we have been doing it for so many years, irregardless of the fear that we have, but it is actually easy as long as we calm down and we use our diagrams effectively. Indicate all the information. You are discouraged from just writing everything, but all statements must be accompanied with correct and valid reasons. I don't know what happens in the exam, but you just find people writing a reason, triangle, square. There is no reason in our acceptable reasons of examination guidelines where you find a reason written as a triangle. We have to be specific, and let's use the theorems. Once you master the theorem, the reason always comes easily because it's actually shorter than the theorem. Now, you cannot use a follow-up theorem to prove a theorem. Like I said, if you are supposed to prove that a line is a tangent, there is no way you can start writing angle this is equal to angle that tan chord theorem, because it has to come at the end. Let us always be careful about that. We cannot write correct but irrelevant statements or reasons and hoping to get marks. For every statement, it must be relevant to the question and the reason must be valid. And then emphasis is on the importance of writing the correct order of steps if we are supposed to prove a theorem or we are supposed to prove a particular question. I've been emphasizing this. You do not start with what needs to be proven. It has to come at the end. Use of color is encouraged. I've been showing you those angles that you must make. Mark them fast. Please refrain from making assumptions. If it's not stated that it's a diameter and it's not shown to be passing through the center, then you cannot assume it's a diameter because it looks like. If it's not, you are not told it's a tangent, we cannot assume it's a tangent if we are not told it's a tangent. I thank you. Let's continue to practice, and we are going to meet again before we write our paper 1 and paper 2. Let's continue to practice and let's visit our Pocket School for the previous lessons that we have gone through so that we keep on practicing, and we encourage you to watch the videos so that you are able to work at your own pace and you are able to pause to see where you are missing the point and you get it from another voice. Thank you. Enjoy your afternoon.